Last Wednesday we were dealing with factoring, so I want to review factoring to some extent here. So we're going to have 7x to the fifth plus 7x to the third minus 140x. So when we look at this, let's go through the process. Can we factor this? What's our first thing we always look for? GCF, greatest common factor. Is there one here? 7x. So if we divide that by 7x, what's left over?
X to the fourth plus x squared minus
20, right? So yeah, x to the fourth plus x squared minus 20. So now, inside here, we have to see if we can factor this trinomial. What should we try? 5 and 4. Now it's a negative 20, so which one should be plus and which one should be minus?
You're going to need a plus 5 and a minus 4.
Okay, so is it x plus 5 and x minus 4?
Yep.
Careful. X squared, there we go.
You got it.
Because it was x to the fourth and x squared, we have to have x squared in there. X squared times x squared gives us x to the fourth. If we double check that, the outside, x squared times negative 4 is a negative 4x squared. Inside, 5 times x squared is positive 5x squared. That does give us 1x squared or just x squared. So we're done there, right? That sheepish grin should give you a clue. What can we still do?
Oh, yeah. X and X.
Okay, yeah, the x squared plus 5 stays the same, but the x squared minus 4 is a difference of perfect squares. So you're absolutely right. It's x and x. What else? Plus 2 and minus 2. Perfect. Because that negative 4 is 2 squared, and it's a sum and difference product, plus and minus. That should be it. Any questions there? Okay, so we might have something that looks like this. Actually, I'll put plus there. Tell me what to do with that. So we can take out a 31x to the fourth. Very good. What's left if we divide out that 31x to the fourth? X to the third plus 1. Very good. Now you're probably suspecting that we're not done yet. What can we still do with that? That's the sum of a perfect cube. Remember, for squares, we can only factor it if it's a difference of perfect squares. But for cubes, we can factor either one, the sum of the perfect cubes or the difference of perfect cubes. Do you remember the pattern? If I'm looking at this, A is going to be, what's the cubed root of x? Yeah, cubed root of x to the third is just x. b is going to be, what's the cubed root of 1? 1. So this is going to be x plus 1. Remember, this was a squared minus ab plus b squared. So what's my first term going to be? X squared, and then minus x and plus 1. Good. Now this sure looks like it should be factorable, but it is not. So we are done there. Now there are a few different reasons why factoring is important. One of the big ones is something we hinted at it a little bit at the end of class on Wednesday. It is solving quadratic equations. And a quadratic equation is any equation where the highest power is a 2. In other words, it has a degree of 2 if you're talking about, in terms of polynomial terminology. And there are simple quadratic equations and there's more complex quadratic equations. We might run into seven x squared minus 3 equals 25. If I go to solve this, what do I have to do? Okay, there's two methods we can go about. In this one, the variable x appears how many times? Once, yes. If the variable appears only once, we can go ahead and just solve the equation. In other words, we look at how it was put together and we take it apart. This equation was put together, x was squared, then it was multiplied by 7, and then the 3 was subtracted. If I wanted to take it apart, what would I have to do? We would add 3, right? 7x squared is 28. What could we do from there? Divide by 7. So x squared equals 4. And finally, square root. So x would equal, 2 or negative 2. You could either write it out as 2 or negative 2, or you could write it as plus minus 2 like that. The other way that could have been handled is the way you started in on it, Ezra. Is to get it equal to 0. Yeah, really it is. So to make it equal to 0, everything's already on the left side, so to make it equal to 0, we would subtract the 25. So that's going to give us 7x squared minus 28 equals 0. And then it would be a matter of factoring it. Factoring it, the first step is going to be the common factor of 7. If I divide by 7, I should probably give myself some space here. If I divide out the 7, this is x squared minus 4. And of course that can still be factored as x plus 2, x minus 2. Very good. It's the difference of perfect squares. Now that it's in this form, we use that zero product rule. And what we had mentioned is the zero product rule states if A times B equals 0, then either A equals 0, B equals 0, or both. Both could equal 0. So what that's telling us up here is, can 7 equal 0? No. That doesn't give us a possible solution. X plus 2, however, can equal 0, or x minus 2 can equal 0. So we have two linear equations to solve here. X plus 2 equals 0, what are we going to do to solve it? Subtract 2 to get x equals negative 2. X minus 2 equals 0, how do we solve that? Add 2 to get x equals 2. So just like we saw up above, the solutions are x equals negative 2 or x equals positive 2. In this simple case like this where the variable appears only once, it just has that squared on it, I think it's much simpler to just go ahead and solve it like we would any other equation. Look at how it was built, how it was put together, and then take it apart. This process we did down here is longer in this case, but there are many equations we run into that's going to be our only possible method of solution. For example, we might have something simple like 5x squared equals 15x. No matter how hard I want to, I can't solve this using standard methods. Now you might be looking at that and say, well, why can't I just divide out an x? If I divide by x, well, doesn't that work? 5x squared divided by x would be what? Yeah, 5x. 15x divided by x would be 15. Well, then can I just divide by 5 and get x equals 3? No, I can't do that because there's a solution that gets lost in that process. If I come back over here, we're going to have to go through the full process because the x appears more than once. One of them's an x squared and the other one's just an x. We cannot combine them and then solve it using just our traditional methods. We have to get it equal to 0 and factor. What would we do to get this equal to 0? Okay, we have to subtract one of them, right? Usually I prefer to have the x squared be positive. So since the 5x squared is positive, I'm going to leave it right there, and we will subtract the 15x. So 5x squared minus 15x is 5x squared minus 15x equals 0. Now that it's equal to 0, what's our next move? Yeah, we can factor out a greatest common factor of 5x. If I divide out that 5x, what is left? X minus 3 equals 0. Now we can see that there are two possible solutions. Either 5x equals 0 or x minus 3 equals 0. And we can solve either one of them. 5x equals 0, we solve by dividing by 5. X equals 0. X minus 3 equals 0. We solve by adding 3 to get x equals 3. You'll notice, by the way, what we did over here gave us one of those solutions, gave us the x equals 3. Why couldn't it give us the other one? Well, to give us the x equals 0, what we did here wouldn't be possible because we divided by x. And if x equals 0, we can't divide by 0. So that would not have been a legitimate move. Screw it. So something like this. If we want to try to solve this for x, what do we have to do? We have to set it to 0. That's always our first step. To set it equal to 0. Now here there's about the same amount on each side. The left side has a little bit more. Again, what I'm normally concerned with is where the x squared is. Here's the x squared. Is that positive here? Yes. So I'm going to leave that where it is. I'm going to get rid of everything on the other side of the equation. What do I have to do to get rid of everything on the other side of the equation? I'm going to subtract 4x, and I'm going to do it all at the same time. What else do I have to do? Add 8. Good. Remember, when I add or subtract from an equation, I only have to do it to one digit or one piece on each side. So I subtract 4x here. That cancels that out. On this side, 9x minus 4x is a positive 5x. I added 8 to the negative 8, cancels that out. Negative 2 plus 8 is a positive 6. We have 0 on the right side. We still have the x squared here on the left side. Once we have it equal to 0, step 2 is to factor. X squared plus 5x plus 6 equals 0. What's that going to factor into? X plus 2 and x plus 3. Very good. 2 times 3 gives us 6. On the outside, we've got 3x. On the inside, we have 2x, gives us the 5x. Anybody having problems factoring right now that wants me to go over the factoring a little bit more? Okay. Step 3 then is the zero product rule. So I am going to take and separate those. If x plus 2 times x plus 3 equals 0, then either x plus 2 equals 0 or x plus 3 equals 0. Solving the left one, what do we do here? Subtract 2. X equals negative 2. On the right side, what are we going to do here? Subtract 3. X equals negative 3. So x equals negative 2 or x equals negative 3 are the solutions to that equation. Now, technically, in a quadratic equation, there's a step 4 that we should do. And that is test our solutions. Sometimes this factoring will give us solutions that even though they work out in the factoring, don't work back in the original equation. So we should test both of those answers. So back up here, if x equals -2, that'd be -2 squared plus 9 times -2 minus 2. Does that equal 4 times -2 minus 8? Now I'm going to do the left side first and then the right side and see if we get the same value. On the left side, I should have put that in parentheses, what is -2 squared? 4. 9 times -2? -18. Good. Then we go back to 4 plus -18. -14, and -14 minus 2? -16. On the right side, what's 4 times -2? -8. -8 minus 8? -16. So the -2 works. Let's try the -3. So if we use -3, we've got -3 squared plus 9 times -3 minus 2 equals 4 times -3 minus 8. Let's do the left side first again. -3 squared? 9. 9 times -3? -27. 9 and -27 make? -18. -18 minus 2? -20. On the right side, 4 times -3? -12. -12 minus 8? -20. Any questions? Okay, so I'm going to have you guys try one here. X squared minus 9x plus 25 equals 5. I'm going to give you about 3 minutes to work on that. So what's our first step here? Yeah, we have to get it equal to 0. The x squared is positive over here, so we're going to subtract 5. So what's that give us? X squared minus 9x plus 20 equals 0. What's our next step? We factor. I kind of gave it away that there's no common factor. What do we get from there? X minus 4 and x minus 5, that equals 0. Good. Any questions so far? Okay. What's the next step? X minus 4 equals 0, or x minus 5 equals 0. So what's this one give us? We add 4 to get x equals 4. Or on this side, we add 5 to get x equals 5. Did anybody double check them to make sure both work? Good. And they should both work in that equation. So if we have something like this, where do you suggest we start? Okay. We have to get it equal to 0. But in this case, the x squared is negative. So we want to make it positive. So we are going to add the 7x squared. So this side's equal to 0. Now over here, 175 plus 7x squared, I could write it like that. But we prefer to have them in that decreasing order, or descending order. So we're going to write it as 7x squared plus 175. What do we do from there? Okay, well, factor out a common factor of 7. If I divide by 7, what do I get? X squared plus 25. What do we do from there? Careful. That's the sum of perfect squares, isn't it? That cannot be factored. So right now, we know that x squared plus 25 has to equal 0. That's not factorable. If we subtracted 25, x squared equals negative 25, we couldn't take the square root of both sides because you can't take the square root of a negative. At this point in what we're doing, we're stuck there. There's nothing more that we can do with that. Now in a few weeks, we're going to learn about imaginary numbers, how to take the square root of a negative. At that point, we will be able to solve an equation like this. We might have negative 56x squared plus 14 equals 0. Now looking at this one, we have a couple of options. It's already equal to 0, but if we look at the x squared, what do we notice? It's negative. We could go ahead and add, the 56x squared to both sides and subtract 14 from both sides. That would give us a positive x squared, but we don't have to go through that much effort. One thing we can do to make that positive, since it's already all on the left side and the right side is 0, is to just divide out a common factor of negative 1. Now, there's actually a bigger number that would divide out of both of these. 56 and 14 can both be divided by what? 7 would divide out of them, but there's even a bigger one. 14. So I'm going to divide by negative 14. So I'm dividing out the common factor, but I'm making it negative, so it changes that to a positive x squared. Negative 56x squared divided by negative 14 gives us what? Positive 4x squared. Good. And then 14 divided by negative 14 is a negative 1, minus 1. Now, of course, we recognize that as difference of perfect squares. So 4x squared, what's the square root of that? 2x. We got 2x and 2x. Of course, the square root of 1 is 1, so we have plus 1 and minus 1. Can negative 14 ever equal 0? No, we're not going to worry about that one. 2x plus 1 can equal 0, however, or 2x minus 1 can equal 0. What do we do from here? Subtract 1. 2x equals negative 1, and then divide by 2. X equals negative 1/2. How about over here? Add 1. 2x equals 1, and then divide by 2. X equals 1/2. So x equals negative 1/2 or x equals positive 1/2. We should go back up to that original equation, make sure they both work. At this point, I know they both work, so I'm not going to do it, but I trust that you guys know how to double check them. So as we look at this one here, we have, oops, I got the wrong number up here. That'll work out a lot better. We need to make this equal 0. How are we going to make it equal 0? If we add 120x, it'll make it equal 0, but we're going to have a negative. It's not x squared, it's x to the third, but we want that highest power of x to be positive. I could add 120x and I'd divide out a negative since there is going to be a common factor here. That would definitely work. I want us to get in the habit, though, of identifying that highest power of x, and if it's negative, getting it positive right away. Unless this last example, of course, where we had the negative 14, it was already equal to 0, so factoring out that negative was the easiest way to go. But here, since we have that negative 3x to the third, I am going to add 3x to the third to both sides. Now that gives me a positive for my highest power of x, but I'm not equal to 0. What more am I going to need to do? Subtract the 9x squared. So I can do both of those at once. So on this side, the 3x to the third cancels out. 9x squared cancels out. I have 0 there. On the right side, I have a plus 3x to the third, so that's just a positive 3x to the third. Minus 9x squared, so negative 9x squared. And that is a negative 120x. Doesn't matter which side the 0 is on, it still equals 0. What can I factor out of this? 3x. When I divide by 3x, what do I have left? X squared minus 3x minus 40. Good. Are we done? No. What do we have to do? We can do that reverse multiplication, right? We got x and negative 8 and plus 5. Okay. If you do your check, yeah, you've got a positive 5x, negative 8x. That does give us negative 3x. We're good. Can 3x ever equal 0? Yes, it can. So that is contributing a solution to this. X minus 8, of course, can equal 0. X plus 5 can equal 0. So there are going to be 3 solutions to this. How do I solve this first piece? Divide by 3, x equals 0. How about the next piece? Add 8 to get x equals 8. And this last piece? Subtract 5 to get x equals negative 5. Those are our 3 solutions. So we should try them to see if they work. Again, I'm going to trust that you guys can test them. Well, they're not always quite that clean and simple. Just because I always make it worse, let's do something like this. Now, at first glance, you might look at that and say, oh, that's easy. Just, set them each equal to 0. But what's the problem there? Anybody see it? The major problem on this one is it's not equal to 0. So what are we going to have to do with it? We're going to have to, before we can subtract the x, we have to multiply it out. Good. So x times x is x squared. X times 8, 8x. 3 times x, 3x. And 3 times 8, 24. So this is x squared, 8 and negative 3 make, plus 5x, plus 24 equals x. It's not, is it? That should be a plus 3. So that should be 11x. Thank you. Now what? So now we subtract x to get okay. Now what? So now we refactor it. X plus 6, x plus 4 appears to work, doesn't it? And then? Okay, so we've got x plus 6 equals 0, or x plus 4 equals 0. Separating it out. Subtracting 6. X equals negative 6, or subtracting 4, x equals negative 4. What do you think? Loads of fun? Okay, so what if we have... Yes, you'd want to go back to the very original to double check it, just to make sure. Try this one in your notes. I'll give you a couple minutes. So our first step is going to be to multiply this out. We get x squared minus 10x plus 24, correct? Equals x. What do we do then? We We subtract x from both sides to get x squared minus 11x plus 24 equals 0. Then what? We can factor that to get x minus 3 and x minus 8. Of course, we split that. X minus 3 equals 0, or x minus 8 equals 0. And of course, we'll add 3. X equals 3, or we add 8. X equals 8. Both of those should work if we double check them back in the problem. Perfect. Any questions? I want you to give this one a shot in your notes quick. I'll give you about 3 minutes on that one. Where would we start on this? So we distribute the x and we get perfect. 4x squared minus 11x equals 3. What's next? Subtract 3 from both sides to make it equal 0. 4x squared minus 11x minus 3 equals 0. And then? Factor. We have a couple choices. We can either have 2x times 2x or 4x times x. Which one did you go with? 4x times x. Okay. And then? Plus 1 minus 3. That does check out. On the outside, 4x times negative 3 is negative 12x. 1 times x is positive 1x. That does combine to make negative 11x. So then we've got 4x plus 1 equals 0, or x minus 3 equals 0. What do we do from there? Okay, so over here we subtract 1. 4x equals negative 1. Dividing by 4. X is negative 1/4. Or over here we could add 3 to give you x equals 3. Any questions there? So looking at this one here, we can get this equal to 0 by subtracting 4. 8x to the third minus 5x squared plus 100x minus 4 equals 0. I'm thinking I did something wrong here. I don't see any way this one's going to work out. Oh, that's why. I wrote it down wrong. 56x squared. That makes a big difference. So now that we have this equal to 0, we have to figure out some way to factor this. Grouping would be the way I would attempt to do it. Let's try to group these first two and the last two. So what can I take out of the first two? 8x squared. What's that going to leave me with? X minus 7. Okay. Over here, what am I going to do? Factor out a 4. Leaves me with? Perfect. Does that do anything for us? It does not. Why doesn't it do anything for us? Well, we can't even do that because these two have to be the same in order to be able to go any further with grouping. If those two aren't the same, we are done here. It's not factorable. But we might have something like 12x squared. So let's do 12x to the third minus 4x squared. I'll get this right eventually. Minus 4x squared. And then plus, ever one of those days where your brain just will not turn on for the day? I am in the middle of one of those right now, and it's frustrating me. We'll leave this one simple. So this one, of course, has 4 terms in it. There are no common factors, so we're going to resort to grouping. So we'll try to group the first two and the last two. It's in descending order, so it makes sense that we should do it that way. What's our common factor for these first two? 4x squared. Good. And if we factor out a 4x squared, what is left? 3x minus 1. Okay, what's our common factor for these last two? 25. Oops, I screwed up slightly. This should have been minus and plus, but it doesn't matter. So I divide out that 25, what am I left with? Negative 3x plus 1. Now these are not the same, are they? But I can make them the same by making one little change. What is that? Yeah, dividing by a negative 25, factoring out negative 25 instead of a positive 25. So this becomes 3x, negative 75x divided by negative 25 is a positive 3x, and minus 1. Now, these match. So I can factor those out. I have 3x minus 1 times 4x squared minus 25. Are we done? Say no. No, what do we have to do? Yes. This is the difference of perfect squares. That's going to become what? Perfect. 2x plus 5, 2x minus 5. And now, of course, we have 3 equations. 3x minus 1 equals 0, or 2x plus 5 equals 0, or 2x minus 5 equals 0, and we can solve each of them. Here we would add 1, 3x equals 1, divide by 3, x is 1/3. Here we would subtract 5, 2x equals negative 5, divide by 2, x equals negative 2.5. Here we would add 5, 2x equals 5, divide by 2, x equals a positive 2.5. So why on earth do we care? Why do we want to be able to solve a quadratic equation? Well, there are some complex applications in engineering like beam deflection, finding a center of curvature or a point of, it's called an inflection point where curvature changes from positive to negative. Those are a little beyond what we want to do in this course. But let's take a simpler example, a little bit less practical maybe. But let's say that you guys revolt on me and you decide you're going to shoot me from a cannon. Don't ask where you got the cannon. But you're going to shoot me out of a cannon. And you have this cannon hidden somewhere outside in the ground. Someone will come walking along and fall into the cannon. So you've got the cannon set to shoot me into the air at a rate of 800 feet per second. That's kind of fast, by the way. That's somewhere around 500 miles per hour. The formula that describes the position, the height of an accelerating body above Earth, the height at any given point in time after it's been fired, is the initial velocity times the time minus the acceleration of gravity is expressed with 16 times your time squared. So what's my initial velocity in this problem? 800 feet per second. So it's 800 times t minus 16 times t squared. What I want to know is how long till I splash down and die? How long do I have left to live? Well, what height am I going to be at when I hit the ground? 0. Very good. So now it's already equal to 0, so how do we solve that? We factor. What can we do to factor this? There's a greatest common factor of a 16t. If I divide out 16t, what am I left with? 50 minus t. So now we have two factors there. Either 16t equals 0 or 50 minus t equals 0. Solving the first one, what do I do to solve this one? Divide by 16, I get t equals 0. Does that answer make sense? Well, it actually does, because at t equals 0, that's the moment you fire the cannon, right? Am I on the ground? I am. I'm at ground level. The answer makes sense, but it's not the one we want. We want the answer when I hit the ground coming back down, not going up. Let's solve this one. What do I have to do? I subtract 50 to get negative t equals negative 50, and then 5 by negative 1 to get t equals 50. Does that make sense? Yeah, it does. I have 50 seconds of airtime before I splash down. Should probably come up with a better term than splash down. Sorry. Now, as just a disclaimer, I don't mean to be any insensitive. If any of you know somebody who has come to their end by being shot out of a cannon, I apologize if I've brought back any harsh memories. I have to put that disclaimer out there, sorry. So anyway, let's look at another less silly example. The length of a rectangle is 11 inches longer than its width. The area is 312 square inches. Find the length and width. So as we look at this, area is equal to length times width. We know the area is 312. Can't deal with two variables though, L and W. What do we know about them? L equals to W plus 11. So we're going to change this. We're going to replace L with W plus 11. So 312 equals W plus 11 times W. Now what do you think we should do? Distribute the W. So 312 equals W squared plus 11W. And then subtract 312. This was our squared here, and that was positive, so we're going to keep it on that side. So yeah, we get everything off the other side. So 0 equals W squared plus 11W minus 312. What's next? Factoring, and not a very pleasant one. We've got W times W. Let's look at factoring 312. We can have 2 times 156. That one seemed very helpful? No. We could have 3 times 104. Come on now. That one doesn't seem to do much. How about 4 times, what would be 78? Still not helpful. 6 times 52? Not so much. 8 times 39? 12 times 26? How about, what do I still have here? 16 isn't going to work, but I can do 24 times 13. I think we might have a winner there. 24 times 13 makes 312. What am I going to use here? Plus 24 and minus 13. Very good. So now 0 equals W plus 24 or 0 equals w minus 13. If I solve this first one, I subtract 24. Negative 24 equals w. Does that make sense for a width of negative 24? No. Or, solving this one, I add 13. 13 equals w. Does that make sense? Yes. So we have the width of 13, but we still have to go back up and make sure we've answered our question. If the width is 13, the length is 13 plus 11, or 24. That's very common in these types of problems where you have two answers you're looking for. This turned out to be 24. The other factor gave us a negative 24. I mean, that isn't the correct answer, but it's the opposite of the correct answer, and that is very common in these problems. Let's say that I have a right triangle that has sides of x, x plus 17, and x plus 18. I want to figure out what those sides are. Remember the Pythagorean Theorem, x squared plus b squared equals c squared, where a and b are the two legs and c is the hypotenuse? So a is going to be x, so it's going to be x squared, plus b is going to be x plus 17, so that's x plus 17 squared, equals c is going to be x plus 18, so that'd be x plus 18 squared. Now here's where using those perfect square trinomials is going to help us out. X plus 17 squared will be x squared plus 34x plus 289. X plus 18 squared is going to be x squared plus 36x plus 324. Now what? We can combine on the left side. Very good. Now there's an x squared on each side and both of them are positive, so we go with the bigger one. The bigger one's over here, so I'm going to move everything to the left. So I subtract x squared. I'm going to subtract 36x. And I'll subtract 324. So I have x squared minus 2x minus 33 equals 0. Is that right? Minus 33? 35, isn't it? Minus 35 equals 0. Now we have to factor. We factor that, we're going to get x minus 7 and x plus 5. So that means either x minus 7 equals 0 or x plus 5 equals 0. So you can add 7 here to get x equals 7. Or here you can subtract 5 to get x equals negative 5. X equals negative 5 doesn't make sense because you can't have a side here of negative 5. X equals 7 does make sense. This would be 7. This would be 7 plus 17, or 24. And this would be 7 plus 18, or 25. And that does make a right triangle. So there are a lot of applications of these problem solving with quadratic equations. There are a handful of them in the homework, so I suggest you pay close attention to those. You're probably going to need some of the hints, the helps in the homework. Make sure that if you're using those helps, that you're reading through and understanding why you have to do it that way, because as always, of course, you don't have the helps on the quiz. But you should be looking now at homework. My pen is bugging me today. (8A) should be matching up with the material we covered today. Any questions? Okay, you all have a great day, and we'll see you tomorrow.